All right, thanks, Vu. So thank you again for everyone joining us tonight. As I said, my name is Catherine Porter. I'm the curriculum developer with the Carnegie Mellon Robotics Academy. Also with me from our team is Vu. Vu, you want to give an introduction about yourself?
Yeah, sure. So, hi everyone. I think I see a lot of familiar faces. I'm Vu Nguyen, help out with the Robotics Academy here. So yeah, I'm really excited for Catherine to show off all the hard work that she has put into this this course. So.
All right, so yeah, our team has worked really hard this summer and over the last few months developing this curriculum, coding and computational thinking with Spike Prime, and are excited to let you know that our version with the virtual robot is now available. So this evening, I will talk about what exactly it is, what's included, and the types of assessment tools that we provide, and how you can also access it. And then I'll give you a quick demo of it all for you. We will have time at the end for questions. However, during the course of the webinar, feel free to type in the chat if you have any questions or comments, and Vu and I will do our best to answer them for you. All right. So what is it? Coding and computational thinking. So our goal for this curriculum is not just to teach how to robot, but our goal is to teach introductory programming and computational thinking using robotics as a medium for delivery. So in this curriculum, we provide activities based on real world contexts to broaden students' thinking from robotics so that they can use it in all other subject areas. So for example, we teach the big ideas in computational thinking, such as decomposition, where we ask students to break down a large task of a challenge into smaller parts as pseudocode. Another big idea that we talk about is identifying patterns, where we ask students to analyze their code and identify patterns, if patterns exist in their program, and whether that pattern can be used as a function or in a loop and stuff like that. So those are some big ideas that we point out. But the point here is even if they're learning these skills through robotics, our goal is to teach this so that they are able to transfer and apply these skills to all other areas. So more about the virtual robot. We designed this virtual robot based on our physical model, Tacobot. And right off the bat, you're probably wondering why we named it Tacobot. And once upon a time, it did stand for something. We decided on something like totally awesome or totally autonomous. And I don't remember what the rest stood for. But if anyone has any ideas on what you think it should stand for, go ahead and let us know in the chat. But in all honesty, our team just really loves tacos. So we thought it would just be a really fun name for a robot. So we stuck with it.
Confession time. Every time we have a chance to celebrate, we usually get tacos. So
yeah, we definitely bond over tacos. So yeah, we love the name Tacobot. Anyways, this is virtual Tacobot, and it's designed to run and react just as the physical version would. So it contains simulated versions of the motors, sensors, and other components. There is also a built-in sensor dashboard that you can view sensor readings, and also a close-up view of the pixel array of the hub. And I will demo that all for you in the demo. All right, so what's included? We have a few different types of virtual activities, and the first one is direct instruction. So with this virtual activity, there is a curriculum content viewer on the right side of the window where you can click through the pages, and each page is a different step that helps students build a program. So when students first learn a new concept, they go through these direct instruction steps step by step. And these are carefully scaffolded as it tells them which blocks to drag over, what that block does, and how the robot will react to it. The next type of virtual activity is a try it. So these types of activities come after the direct instruction. So after students complete the direct instruction activity, they can move on to a try it, and these allow students to modify their code and observe how the robot will react differently. So for example, if students just learned how to program the robot to turn, this try it tells them to modify that code so that the robot can turn 90 degrees. And then we have mini challenges. So the mini challenges come after each major learning concept and provides an opportunity for students to apply that single concept that they just learned into creating a solution that relates to a real world problem. And then we have a unit challenge. So these come at the end of each unit as a final challenge where students are required to apply all the concepts that they learned from the entire unit to create a solution for another real world robot problem. Any questions yet, Boo?
I don't see any yet. So
Okay. All right, so how do we assess learning? The first one is check your understanding questions. We call them CYUs. And these appear at the end of each lesson. So these are informal questions as they are not graded, but they give immediate feedback so that students can check their understanding before moving on. I think I skipped one. So then we have quizzes. More formally, we provide a quiz at the end of each unit that asks questions about the content from each lesson. And then, as the teacher, you are able to see quiz attempts and scores in the progress viewer from your group, which I can show you how to get to when we go through the demo. But in progress viewer, you can also see their code for each programming activity that they complete. You can do more than just view their code. You can help students by giving them tips through adding a code comment or even changing their code for them. And that can be done again through that progress viewer. And that brings us to how can I access it? So if you really like this and think that Virtual Spike Prime Robot is for you and your students, you have two purchasing options. You can either buy a single license for $9 or a 12-pack bundle of licenses for $100. And once you have a license, whether you're a teacher or a student, you can use the curriculum if you're at home, school, or anywhere else in the world. All you need is an internet-connected Chromebook, Windows PC, or Mac. All right, so that brings us to our demo. And I'm going to demo how these things look inside of CS2N and give you an inside look at the curriculum. All right, so say I already purchased virtual licenses for all of my students and I have my group of 7 students and I want them to complete the virtual Spike curriculum. Well, inside my group, I can go to the Manage Virtual tab and scroll down and select the Coding and Computational Thinking with the Virtual Spike Prime. Since I have 7 students in my group, I enter 7 licenses and confirm. I can go back to my group and that activity should be here. Then I would have to assign each one. So I can click Assign All so that all of my students have access to the virtual activity. All right, so you can access that progress chart by this button here. It says View Progress Uploads. And this is where you can view the student code and their quiz scores and stuff like that. So if I click this View Student Code, I would be able to see it here. I guess I did not have anything saved here, but the programs are saved. So typically you would see the student saved program there. Let me go back to our group and let's take an inside look at the curriculum itself. This curriculum is made up of Getting Started, Programming the Hub, Robot Movement, Wait Until and Sensors, Loops, Discrete Decisions. We have a capstone challenge about a subterranean challenge by CMU, and then finally with continuous decisions. So I'm just going to show you an example, a few pages of robot movement. And I know that I kept saying earlier that all of our activities are based on real world context. Well, this is what I mean by that. So each unit within the curriculum has a theme robot, which connects the learning content to a real world robot and its applications. So all of the activities and challenges within the unit are designed and written with a narrative that aligns to the theme robot. So the theme robot for this part of the unit is the IRIS rover, which is a moon rover developed by CMU. So all of our challenges are designed to complete a task in space. And you'll see exactly what I mean by that in a moment. But for now, I'll show you an example of one of our lesson pages. Go to Turning in Place. And as before, our first virtual activity is the direct instruction. So you can go inside the virtual activity by hitting this Launch Activity button. And you'll see you have the programming canvas in the center and the robot simulation window that can be moved around and expanded. We have the blocks on the left, and this is a customized toolbox. So students only see what they would need at the lesson. We don't have like every single category of blocks, just the ones that would be needed for this unit. So we have the content viewer on the right, and we can click through the pages. It tells me to drag this block here to turn, and I can click play. And if it does it right, I get a nice job. So within this virtual window, I have a few different camera options. So I can either stay here in camera 1, which follows the robot. I can zoom in and out and turn it around different angles, or I can do top-down view, which just gives me a whole view of the entire board. This button shows me a close-up view of the programming hub. So just to give you an example, if I use this matrix light button and I run it, I can see my smiley face. Let me do that for a longer amount of time. Can see the smiley face on the close-up view of the hub here. This is for the sensor dashboard. So we can have a view of the distance sensor, force sensor, color sensor. If you click this here, what else? So that's direct instruction. And if you scroll down, we have did you knows. So did you knows, these are like additional sections of content that we usually put at the end of each lesson so that student can have an aha moment. They act as an explanation of what they just learned. So actually, let me scroll down. This did you know talks about arc length and how you use it to determine how much the robot should turn. So I just wanted to point this out to show you that we do sprinkle some math concepts around within the curriculum. And this is just an example of a math concept with arc length and how it's used to make the robot turn. But towards the end, then we have our CYU question. So this is where we have that informal question with the immediate feedback. So you can see what question is right and wrong. And then we have a mini challenge. So as I said, our challenges are based on the real world context. With in this unit, the Iris rover. So this one, we ask to drive to the other side of the table, the virtual table, while avoiding the craters. So if you see, we do have craters here, and using the movement blocks to turn and avoid the craters. Vu, any questions?
There have been a lot of questions. Actually, I've been trying to just handle a bunch of them, but a couple of pretty common questions. Let's see. Actually, there's one question that I wanted to save for you because I think it would be great to answer. And give me just a second. Aha, okay. So Stephen asks, does the virtual software include all of the scratch blocks currently found in the Spike app? I thought that would be a good question to kind of address to the group.
Yeah, so that is a good question. The answer is no, we don't use every single block that you can find in the app. We use all the blocks that we use in the curriculum. So not every block from the app can be found in our CMRA blocks, but all the blocks needed to complete the curriculum can be found.
Yeah, and the reason for that is because the way that Catherine and team have created the course is it scaffolds based on, when you start off, you kind of are given a smaller set of blocks so that you're not overwhelmed by a ton of different options. And then as you kind of get further down the course and it builds up towards kind of more advanced behaviors, more of those kind of what we call toolkits, right, are opened up, which are the additional blocks that they'll need. So it's not intentionally. Yeah. So. Yeah,
Great,
and
well,
some sorry, yeah, I'll point out some other common questions that we're seeing. One of the kind of the most common question we're seeing is, when you get licenses, are they transferable? Are they kind of can you kind of reuse them, or and whatnot? And because the licenses are tied to a particular student account, all of these programs that Catherine are showing, when you work on a challenge, it does save progress, directly on the site. And so, you don't have to, save it on a computer. You can work on it on different computers. And so because of that, each license is tied to that individual account. And so when you start a new semester, students do have to, have a different account. And that's why we kind of chose a kind of a lower price point so that it's more accessible. So, all right.
Yeah, so that's all that pretty much all that I wanted to demo with you. I can go back to the PowerPoint. And this is just to let you know that our curriculum is aligned to standards. And these are all the standards that we used. If you want to look and see what the exact standards are that align to our curriculum, you can find our standards alignment guide on our website. But yeah, just so you know, we do have standards that align to computer science principles, NGSS, CSTA, Common Core, and ISTE.
That's wonderful. I get messages all the time from teachers all over who are looking for particular curricula that are aligned to specific standards. And so, being able to put this out there hopefully is helpful.
All right, and that's all I had to show off. Are there any additional questions that I can answer?
I see, let's see, I see Stephen asks, what info do you need to create a student account? Do they need their own emails? I don't know if you want to take that, Catherine. No.
You can take it.
Okay, yeah, sure. All right, so students do not need an email address. There is a way for you to generate student accounts on CS2N, our learning management system. So you can generate as many accounts if the students do not have email addresses, or if you just want to get started quickly, and then they can just change their account's email later. So that's definitely possible. Another question I'm seeing from, if I'm pronouncing it right, Graham. Do the simulation commands control the robot exactly, or does the simulation include some simulated disturbances caused by an unreliable surface, as has been included in some previous simulations? I'll answer that as well. So we actually made it so that when you run the program, it runs consistently or as close to being consistent as possible. Only because what we want to do is focus on the learning, focus on the behaviors that you're programming, the concepts that you're programming. And we have found that in the past, when we did put in purposefully, variance in like the environment, it actually made it harder for students to learn, because they weren't sure if it was something with the environment, or if it was something with their code or their learning. But we made the choice to purposely have it so that it's consistent, so that for sure that the issue, if they're running into issues, is because of the programming. So, and lots of questions coming in.
Lots of questions.
Yeah, this is great. Let's see, where were we at last? Srini asks how to add additional challenges. So the challenges are made by us, the CMRA Carnegie Mellon Robotics Academy. So if there are additional challenges that you're kind of have ideas for, we'd be totally open for that sort of feedback. But any of those challenges are things that we have to design and create. So.
And Anna is asking, other than moon landing, what other virtual environment is included? So to answer that question, I can just go back to the curriculum overview to show you that each unit has its own theme robot. So actually, even in robot movement, we have two theme robots. Our second one to use the arm is this Locobot. So our challenge here is cleaning the home, since that robot was designed to help people pick things up in their house and organize things. We have this challenge to pick up utensils and throw away trash. So we have quite a few different theme robots with different challenges that relate to those. So this
Yeah.
is just another example.
Yeah, that's and you know, with these real world robotics applications, like the robots that are actually out there, it's a wonderful way for us to just kind of tie in, you know, give the students the why. You know, why am I learning this? Well, you know, there are real robots that are using these particular behaviors, and so, you know, it's just a wonderful way to set the context. And then I think we did a count of the number of activities or virtual activities, something like 70, a little over 70 virtual activities.
75?
Yeah, something like that.
Something like that.
That was quite a
Lost
bit.
count.
So yeah, a lot of work was put into this. So let's see, Thomas asks, is the license only good for just one curriculum? Per license, yes. So you assign it and you assign it per virtual course. We do have a few virtual courses available. This one's our latest and greatest that's out there. So you would need a license per, and like I said, it's, you know, set to be lower costing for that reason. Oscar asks, which age/grade start? This is actually, so we typically recommend around the kind of the middle school. It's kind of the sweet spot of the curriculum, but if you're familiar with any of our work, it's more of an experience level. You know, we've seen students kind of start even as low as, you know, third grade for some of our kind of programming courses. So it's all kind of dependent on kind of the experience level of your students as well. Granted, we start basically learning from scratch, nothing, so they can start off with not much experience. So
Chris is asking, if I ran the curriculum, are you imagining it is appropriate for an after-school program or a club that meets a few times a week? So we designed this to be more of a formal curriculum, but we do have an informal virtual Spike Prime curriculum that we developed this summer that is called RoboCamp with Virtual Spike Prime. That's our informal version, and we say that that's good for like summer camps and after school programs. And this one we would say is more formal.
yeah, and then it's one of those things where it's really dependent on the makeup of the after school program. You know, if some programs, if you have them for you know, sporadically, and maybe the kids are very self-paced, self-motivated learners, it could work, right? Because it's all very step-by-step, very self-paced. And if they're kind of jumping in and out, as typical with an after-school program, at different times, right? Different kids show up sometimes for an hour or two a week, and they may not show up the next week. If you're comfortable with that, and they're there to kind of learn at the time that they have, it may take them longer, right? But yeah, it just depends on kind of the makeup of how the after school club works. So, all right.
I lost track of the next question.
Yeah,
do you have any free trials or scholarships? So free trials, we do have a preview. What do we call it, Vu?
It's the
Iris challenge.
Showcase. The showcase.
Showcase. Yeah. Thank you. We do have a showcase badge where you can do like a short trial version of the curriculum that pretty much, I think, just goes over movement. And that's available for free, but it's not the entire curriculum.
Yeah, and that's also helpful to make sure that the technology, like it actually works fine on your computers, machines. And you kind of can get a taste of how it's going to work, how you're going to run it. But it could be used for, a good, depending on how much time you have with them, good, 5-6 hours worth of material. So, all right.
Are there books recommended for additional learning? Boo, do you have an answer for that?
I mean, there are a lot of kind of Lego and education books that are out there. I don't have any off the top of my head because there are just so many options available out there. But maybe it's something that if you drop us an email, maybe we can try to point some out to you. So, let's see. Chris asks, is it more appropriate for coding curriculum block inside a tech class, a month of classes? Is it more appropriate for a coding? Oh, I missed that word. A coding curriculum block inside a tech class, a month of classes. So I guess I kind of ask for some more detail. How much time do you have within that month, right? So you can imagine that something like this could take anywhere from 40, 50 hours of activity, depending on how much time you have with the students. So if you have them for quite a bit of time throughout that month, you could probably get them through. Just depends on, again, how much time you have with them. And you can always, chunk it, give them a little bit, or so, the first few badges or something.
There's this other question that I think is asking, it's from Stephen. Basically, how long do they have access to the curriculum for?
Yeah, that's a great one. And they actually, once you apply to a student account, they have it for good. As long as we're around, they'll have access to the course. So they can always go back and play around with it after, even if they've completed the activity. So, our good friend Joey asks, is there any way to enable/disable mini challenges or lessons in the educator dashboard? And that's actually, I'll take that one. That is a wonderful suggestion or question. We've actually had that question a few times now, and it's starting to kind of creep up on our features kind of queue. The ability to kind of tailor, right, or turn on or adjust the type of activities that you'd like your students to have. And more we're seeing that request. So it's definitely something that's on our radar. We currently don't have that. It's kind of you add in the activity in your group. You can add like the course in your group, but we can't like disable or enable pieces yet. All right.
Stephen is asking, are there build directions so that students can build the bot that matches the virtual one? So this curriculum, Coding and Computational Thinking with Virtual Spike Prime, is pretty much a mirror image of our physical version. So within our physical version of the curriculum, we do have build instructions on how you can build Tacobot and all of the challenge props that we use with it.
All right, next one. A grade 3 student of mine completed that collection activity yesterday. She found it interesting. Oh, wonderful. That's awesome. All right. Thomas is asking, what is the prime access for $300? So that is, for those who haven't seen, on CS2N, which is our learning management system, there is an option to be able to have premium access. And that is only if you have, if you need more than 30 students per group, or more than 3 groups. If you need more than 3 groups or 30 students per group, then we require purchasing a yearly $300 premium access account. But we purposely chose that number because the typical classroom has less than that. So you wouldn't need it unless you have a very large, kind of group. And then the only reason we do that is just because we are a small research group, and it kind of helps to help us to sustain kind of the servers that we try to help provide for free for everyone. So. Let's see, where are we now?
I'm looking.
V. Ramirez. How can we integrate this curriculum with the regular Spike curriculum? You want to take that one?
Sure. So a way that if you want to use both, you can use physical inside of your classroom with your students. But if you have students who are missing some days, or if you have a snow day or COVID cancels your school, then you can use virtual while you guys are working from home or doing distance learning. So just kind of situations like that. Yeah. Did you want to add anything to that, Vu?
Yeah, that's a great way to put it. You can add, since the physical Spike Prime curriculum is free, all of our kind of physical robot curriculum is free. You just create a group, add in the physical one, you'll get the virtual one, and you'd basically be covering your bases for for any situation. All right.
What
Chris,
target grade level did you have in mind? So developing this, we figured that this fit best with middle school students, upper elementary, like 5th grade. So basically middle school. And for
Sereni,
sorry,
for, no, sorry.
I was just trying to read the next question.
Yeah. For kids who completed EV3 Mindstorms with Virtual Brick, this is add any other value. So the kids who have already done, so Virtual Brick was a software that we used to use with our old course with the EV3, which is no longer supported. This is similar in kind of the structure, because it kind of does go into like the introductory kind of programming concepts, and this adds in a couple of pieces, including a heavy emphasis on pseudocoding as well. Something that over time and with our research, we found to be incredibly helpful to kind of point out and add in specific methods to doing pseudocoding as well, and also highlighting a lot of the big ideas behind computational thinking, and in programming concepts. So there is a bit of overlap. I'm just being completely blunt, because it is based off of that particular course. But there are additional, new challenges, new platform, new language. So that sort of kind of piece helps to add that excitement. So, all right.
I think the next one is how many minutes, hours do you estimate the course would take? I know there is a wide variety. So I think Vu mentioned that we estimate that this would take about 40 hours to complete straight, but it depends teacher by teacher and class by class how long it's going to take you to complete those 40 hours. So say you see your students once a week, or say you see your students every single day. So it could take you up to 3 weeks to complete, or it could take you up to 3 months, depending on how often you see your students.
There's actually a good question by D. Mackin, my good friend. And I have 5 classes with about 20 students in each class, I would need premium. And so it depends on if you have them all at once. If that's the case, it sounds like yes. However, if it's not all at once, then you would just kind of remove the group, add a different group, and you wouldn't need to. So, we hit up the last question here. Chris asks, I used all the Atlantis challenges during COVID. Really a big help. Oh, that's wonderful. Not a question, more of a glad you were able to use that.
All right, well, that's all that I wanted to show off with our new curriculum. If there aren't any other questions, then thank you all so much for joining. It was really nice to see a lot of familiar faces. So thank you again, and stay in touch with us.
Yeah.
I hope you like Virtual Spike Prime.
Yeah, thank you everyone for taking the time out of your busy days, all right? Have a great evening or great day, depending on where you are in the world. And hope to hear from you soon. Bye, everyone.
Bye.
I have a question, Catherine.
Sure.
So I teach for after school programs like the Boys and Girls Clubs, and there we